Multiplying and dividing monomials. A monomial is a number, or a variable, or the product of both a number and a variable. The variable can have exponents, but only if they are whole and positive. Below I listed some monomials and examples that are not monomials. If you look at the difference of the two, you'll notice that when they are products of the number and the variable, the exponents are raised to a power, and those powers are positive in whole numbers. If you look at the examples that are not monomials, the variables are raised to powers that are fractional or negative. If you notice the 2 plus a, this is not a monomial because the 2 and the a are added to one another instead of them being a product, so they're multiplied. To multiply monomials, you need to multiply the coefficients and add the exponents that have the same base. We learned in the other lesson that when you have the same bases that are raised to a power and they are multiplied, you simply add the exponents. So let's look at this example. I have 5x to the third power times negative 7x to the fifth power. We separate the coefficients first, so I have 5 and the negative 7. And then I separate the variable, which is the x to the power of 3 times x to the power of 5. 5 times negative 7 is negative 35, and since the variable is the same, it's the same base, I raise it to a power of 3 plus 5. The result is negative 35x to the power of 8. Let's try an example together, and feel free at any point to stop this video and try to finish it on your own. Let's do 4a to the power of 2 and b times 6a to the power of 4, b to the power of 3. I'll start off by separating my coefficients. So I have 4 times 6. And then I'm going to separate all my variables, all the like terms. I'll have a to the power of 2 times a to the power of 4 and b to the power of 1 times b to the power of 3. And simplified, this would be 24 a to the power of 2 plus 4 and b to the power of 1 plus 3. My result is 24 a to the power of 6, b to the power of 4. To divide monomials, you divide the coefficients and you subtract the exponents that have the same base. So just a gentle reminder that when you have the same base and you are dividing, you are going to subtract the exponents. So let's look at this example. I have 12y to the third power z to the ninth power divided by 8y to the fifth power z to the fifth power. All right, so let's simplify this. I have 12 over 8 y to the power of 3 minus 5 z to the power of 9 minus 5. Notice the 12 divided by 8. I don't have to find a number that goes into it evenly. So I'm going to simplify that. So I think of a number that goes into 12 and 8, and that would be 4. So it's simplified to 3 halves, and then y is to the power of negative 2, z to the power of 4. To write this in simplest form, I can't write it with a negative exponent. So if you remember from the other lesson, when you have a negative exponent, you simply write it under 1 and you raise it to the same power, but now it's positive. So instead of y to the power of negative 2, it's really 1 over y to the power of 2. 1 times 3z to the power of 4 remains as 3z to the power of 4, and I write it under, or divided by, 2y to the second power. Now let's try an example together. All right, let's do 32 x to the power of 4, y to the power of 7, divided by 16 x y squared. We'll start with coefficients. I have 32 divided by 16, and then I have x to the power of 4 minus 1. A huge misconception is when students see an x, they forget that it's actually raised to a power of 1. So don't forget, you're really subtracting 4 and 1. And then I have y to the power of 7 minus 2. So 32 divided by 16 is 2. So that would be 2x, 4 minus 1 is 3, to the power of 3. And then y, 7 minus 2 is 5. So y to the 5th power. And you're done. Next and last of all, we have raising monomials to powers. And when we have a monomial raised to a power, the coefficients are raised to the power, and we multiply the exponents that have the same base. Looking at this example, I have 3bc squared, and that entire monomial is raised to a power of 3. So it's really 3bc squared times 3bc squared times 3bc squared. I will separate the like terms. I have my coefficient, which will be raised to a power of 3, so it's 3 to the power of 3. And then b, remember it's to the power of 1, 1 times 3, and then c raised to the power of 2 times 3. 3 to the 3rd power is 27. That's 3 times 3, which is 9. 9 times 3 is 27. And that would be b to the power of 3, c to the power of 6. All right, let's do an example together. I have 9x to the power of 3, y squared, and this entire monomial is squared. So let's separate the coefficients. So the 9 is raised to the power of 2, and then x to the power of 3 times 2, and then y 2 to the power of 2, so it's 2 times 2. And in simplest form, 9 squared is 81, and that's x to the power of 6, y to the power of 4. And you are all done.